Before I start, allow me to introduce myself. My name is Nizam bin Indrawaty from Faculty of Electrical and Electronic Engineering Technology, University Technical Malaysia Melaka. I'm here to present my Bachelor degree project with the title Assessment on Potential Energy Storage Technologies for Urban Rail Transportation System. And the first part is project description. Supercapacitor used as energy storage system to capture regenerative energy produced by linear induction motor of urban rail transportation during braking. And for this project, I have three objectives. And the first one is to identify the way in which regenerative energy recovered by using a supercapacitor in Malaysia's urban rail transportation system. And the second one is to analyze the charging and discharging behavior of the supercapacitor during regenerative braking using simulation software. And the final objective is to evaluate the appropriate size of the energy storage system for the urban rail transportation system in Malaysia. For the problem statement, according to the Energy Commission, the urban rail transportation system in Malaysia consumes a lot of energy to operate. While consume energy, urban rail transportation able to generate energy. The generated energy will be wasted if not used entirely. And for the project methodology, I start with preliminary research work, which is to review previous literature. And next part is ESS configuration, which is to determine the configuration used for this project, which is either onboard energy storage system or wayside energy storage system. And the next part is ESS design. For this part, I will design for single cell supercapacitor, which is the design is based on XL60 supercapacitor by Eaton. And the next part is ESS size, which is in this part I will design several modeling, which are small size, medium size and large size. And the next part is result analysis and discussion. For this part, I will do the analysis for all three simulations and do the calculation. And the next is final documentation. All report will be documented. And for the result and discussion, here I include one of the modeling, which is small size energy storage system modeling. At the top here is the schematic diagram for the design, and at the bottom here is the output result, which show the current and voltage level during charging and discharging. Conclusion: out of three energy storage system modeling, small size energy storage system is the most suitable due to the less cost and more efficient than the other two models. Project features: by using PLEX software, the energy storage system can be designed and set the parameter of supercapacitor to obtain the result. Project potential of commercialization: energy storage system is crucial in urban rail transportation for energy recuperation, which is to store the energy, and voltage stabilization to regulate the voltage, emergency supply to back up the system during power outage, and reduce peak demand to reduce peak demand during peak hour. And here are some of the reference I use for this project. And next, I will demonstrate for the simulation. This is the single cell supercapacitor modeling, and as you can see here, this is charge and discharge controller to control the simulation, and this is the scope to obtain the output result, and this is the supercapacitor. For charge and discharge controller, the parameter has been set with charge current 2400 ampere, discharge current negative 2000 and 400 ampere. Charge start time at 2.5 seconds. Maximum discharge time 2.5 seconds. Maximum charge time 10 seconds. Minimum voltage 0 volt. Maximum voltage 3 volt. And start with the simulation. This is the output obtained from the simulation for charging and discharging. And here the current able to fully charge at 5.4 seconds and able to fully discharge at 14.8 seconds. And this is the voltage when charging, and this is the voltage when discharging. This is small size energy storage system modeling. This modeling has been designed based on single cell supercapacitor, and as you can see here, this unit represent 250 unit supercapacitor in series with 12 string connected. And to design for the bigger system, the supercapacitor need to be connected in series to obtain the rated voltage, and to increase the power, the supercapacitor need to connected in parallel. And for charge and discharge controller parameter, the charge current is 4000 ampere and discharge current negative 4000 ampere. Charge start time at 2 seconds. Maximum discharge time 8 seconds. Maximum charge time 8 seconds. Minimum voltage 0 volt. Maximum voltage 750 volt. And for the supercapacitor parameters, rated voltage 750 volt, V initial 700 volt, DC capacitor 12 volt, voltage dependent capacitor 1.2, DC resistance 0.0575 ohm, and leakage current 1.75 ampere. And for the simulation, so this is the result obtained from the simulation for charging and discharging. The current able to fully charge at 10 seconds and able to fully discharge at 18 seconds. And this is the voltage when charging, and this is the voltage when discharging. This is medium size energy storage system modeling. Basically this modeling is the same with small size energy storage system modeling. The only difference is the string is 33. And for charge and discharge controller parameter, charge current 4000 ampere, discharge current negative 4000 ampere, charge start time 2 seconds, maximum discharge time 24 seconds, maximum charge time 24 seconds, minimum voltage 0 volt, maximum voltage 750 volt. And for the simulation, so this is the simulation obtained for the simulation charging and discharge, and the current able to fully charge at 26 seconds and fully discharge at 50 seconds. And this is the voltage when charging, and this is the voltage when discharging. So this is the last modeling, which is large energy storage system modeling, and this model increase the number of string up to 54 string. And for charge and discharge controller parameter, charge current 4000 ampere, discharge current negative 4000 ampere, charge start time at 2 seconds, maximum discharge time 40 seconds, maximum charge time 40 seconds, minimum voltage 0 volt, maximum voltage 750 volt. And for the simulation, So this is the simulation obtained for charging and discharging. The current able to fully charge at 42 seconds and fully discharged at 82 seconds. So this is the voltage when charging, and this is the voltage when discharging. That's all for me. Thank you.